Okay, it's already 11:30. Okay, let's start. Okay, so for the first question here, okay, we have the first three terms in this expansion in the ascending powers of A. So for this one is by just using the usual formula law. So for expansion, if we have 1 plus x to the power of n, so this one will be 1 plus nx plus n minus 1, 2 factorial x squared, and just continue the terms from there. Okay, so this formula can be obtained from the MF19. It's very easy to use. Just make sure that we be careful with the negative terms because in this case our x here is a negative 4a, so whenever there's a negative we need to include the negative together, and whenever we want to do this expansion, always make sure that the constant that we have inside is a positive one. If it is something else, remember to just factorize that out. Okay, so by doing the expansion, okay, we'll actually get the result for this, which is we'll get 1 minus 2a minus 2a squared from there. Okay, it's not difficult to do. So next one. Okay, we have hence shown that the roots of this quadratic equation given approximately these two values where a is small. So for this, in order for us to solve this quadratic equation, the easiest way for us to start from here is we will actually have to do the formula. Okay, so if you actually have the formula, okay, just substitute all the values of the coefficients here into the formula, and this is what we get. Okay, so the thing that we have here is the positive one we will get from here, and this is a 2. So the thing is we need to simplify what we have inside the square root. Okay, so inside the square root, when we actually simplify, we will get 1 minus 4a. So if since it is a square root, we will have this expression is to the power of half from there. Okay, so that will be our 1 minus 4a to the power of half. Okay, so because we have got this result from the first part, so what we do from there is we just have to separate into two values. So one is the positive and the other one is for the negative, and both of the terms they have 1 minus 4a to the power of half, which we can apply the result from the first part, okay, inside, and we just have to tidy up, and from there we will actually get the two roots, okay, for that quadratic equation. Yes, so if you want to use complete the square, you will also have the similar result. Okay, so with that we will actually have the two values that we need to prove. Okay, so that would be for the first question from there. So let's move on to the second question. So for second question, we have the three terms of the expansion. Okay, 1 minus 2x to the power of half is given by this, and find the next term. So for this one, it's the similar thing. So we have to check the constant is a 1, and from there we can just apply the formula from MF19, and we just expand from there. So the first three terms are already given, so it actually led us to ensure that the thing that we have applied is correct, and they also need the following term. So the following term is just apply from there. Okay, so from there we will actually get the following term will be this, okay, negative half x cubed. Okay, so for the second part from there, we have state the range of values of x for which this expansion is valid. So for that one, right, we have the validity. Okay, how do we actually state the validity of this is that whenever we have got 1 plus something or 1 minus something, okay, in the expansion, okay, so the validity we always take the stuff which is inside the bracket. Okay, so in this case we have 1 minus 2x, so we will actually make the 2x, the modulus of it, okay, to be less than 1. Okay, so from there we will actually have that x, okay, is less than half. We just move the 2 over, so we can write it in this form. Okay, or if you want to actually open up the modulus, we can also write our expansion, the validity of the expansion in this form. Okay, either one will do. Okay, so that would be for part 2. and we have got a part 3. Okay, hence show that the first 4 terms of this expansion are given by this form, and we need to find the values for the a and b in this case. So basically it's by expansion, expand all the terms from there. Okay, so we have got the 1 minus 2x to the power of half. Okay, we have found that earlier on, and we just have to expand, okay, by multiplying with the terms in 2 plus x, and just deal with all the terms carefully from there. Okay, so by doing all the terms carefully, okay, expand, and we will actually have all this, okay, terms, so we can actually find what are the values for the a and b from there. Okay, basically this is not difficult to do. Alright, so we will actually have the second question. Let's look at the next one. So for next one, we have got expand 1 plus x to the power of half. Okay, until we have got the terms in x power 3, simplifying the coefficients. So I guess for the first part, it is not difficult to do. As long as, again, we make sure that the constant is a 1, then we are good to go. Okay, we can just expand from there. Okay, applying the formula, and this is the expansion that we should get from there lah. Okay, so that will be for part 1. For part 2, okay, we have in the expansion of a 2 plus kx times 1 plus x to the power of half, the coefficient of x power 3 is 1. So find the value of the k. So from there, okay, we actually have the expansion, okay, for this term, which will be based on what we have in the first part. So in the first part, we already actually have found out, okay, what are the terms. So basically is to just multiply, okay, this one with the terms with the 2 plus kx, and then basically we just expand from there. And what they need is they need the value of the k, which it is given that we have got the coefficient of the x cubed is 1. Okay, so basically we have to rely on this x cubed term for us to find what is the value of the k. So we have, of course, in this case, we can expand everything and just find out what are the terms which is in x cubed, and then we just work with the x cubed term. That is one way if you don't want to think much. Or another thing is, because they only give us the x cubed term, so we just have to work with the terms which is related to the x cubed. So what are the terms that will be related to the x cubed is that we will actually have. So the first way to get x cubed is to multiply the kx with this x squared term here. So this is why we get this term here. Okay, there's another possibility that we can get the x cubed term is we have 2 to multiply with the x cubed term here. So this is why we get this. Okay, so there is no other way for us to get the x cubed term from the expansion already. Okay, so from there just have to tidy up the coefficient of the x cubed. And then we know that the coefficient of the x cubed here is equals to 1. Okay, so we just have to solve the value from there lah. Alright, so with that we actually have the value for the k is negative 7. Okay, so that will be our third question from there. Okay, so we'll move on to the last question here. So for the last question here is we have got the binomial expansion of 1 plus 2x to the power of p. And it's given that the coefficient of x is twice the coefficient of x cubed. And it is also given that the coefficient of the x squared is a negative value. Okay, so first one is to find the p. So for this one, basically what we do from there is we will have to expand this as usual. So when we actually expand as usual, we just apply, okay, what we have for the binomial expansion formula, okay, based on what we get from the MF 19. And from there, okay, just have to be careful that when we actually work with the values, we have got the 2x, right? So we actually take the powers of the 2x, okay, just make sure that we include the 2 as well. Okay, when we actually take the power, and from there we just have to simplify the values. So p, all those expression in p, we just keep it like that first, and we just have to deal with all the values lah. Okay, so we have got 2 factorial and a 2 squared here. It actually gives us 2, and also we have got 2 cubed to divide by the 3 factorial, and then we actually have this value accordingly. Okay, so from there we have to look at the first information given is this one. Okay, the coefficient of x is twice the coefficient of the x cubed. So the coefficient of x is 2p, which is twice the coefficient of the x cubed, which is this thing. Okay, basically from there is we have to work with the values of the p. Okay, so from there, since we actually have both sides, we also have p, we can actually cancel off from there. Okay, so we can cancel off this one is because the p is not a 0. Okay, we know that the p is not going to be a 0. So if p is a constant and we know that it is not going to be 0, we can actually cancel from there. So this will actually end up with something which is related to our quadratic. Okay, so from there, just work with the quadratic equation, and we will actually eventually end up with two values for the p. And we are not going to find we are not going to use both values of the p because we are going to reject one of it. So this is where, okay, the second information comes in. So in the second information, it says that the x squared is a negative term. Okay, so we have to look at, okay, what is our x squared term again? Our x squared term is given by this one. So we have to substitute the values of the p inside this and check that which one actually gives us the negative. Okay, so if we actually start with the value for the p, which is 5/2, we sub into the value for the coefficient of the x squared, it will actually gives us a positive term. Okay, so we are going to reject the value which we have the p is equal to 5/2. So we are going to accept the value which is p is equal to half. Okay, so from there, okay, that will be the value for the p. Okay, for part B, the validity, okay, of this expansion. So 1 plus 2x to the power of p, we just have to take the 2x and then put that inside a modulus, and it is less than 1. So this is a standard thing that we do for the validity. So we can either write our x in modulus x is less than 1 or 2, just move our 2 to the right hand side to divide. Or we can actually open up the modulus and we will get this range for the x. Okay, so either way we'll do lah. Okay, so that is basically what I want to go through with you all today. So I'll see you all tomorrow in another session. Okay, thank you.